You've just finished running a highly critical batch of clear plastic parts. The process looked flawless until you inspect the final product under the light and spot them, tiny, embedded dark specks scattered beneath the surface. Instantly, that entire batch becomes scrap material. Worse than the lost resin is the machine downtime you are about to face. Every minute that line sits idle while you hunt for the source of the contamination is a minute of zero profit. This image shows exactly what we're up against. Those black carbon flakes trapped inside the clear plastic indicate your system is compromised. In this video, we will execute a step-by-step diagnostic to trace these specks to their source and permanently eliminate them. We need to move your facility away from reacting to these crises with emergency machine teardowns. The primary goal is to establish a routine, preventative mechanical purging process. Mastering this protocol stops machine maintenance from being a massive drain on your schedule. It creates a predictable, controlled process that directly protects your operating margins. Step 1 is realizing that not all black specks are the same. Before clearing the machine, we have to identify whether the contaminant has a mechanical or a thermal origin. Looking at this chart detailing common causes, the first two culprits are usually carbon buildup and polymer degradation. Degraded resin gradually accumulates on metal surfaces, eventually flaking off into your melt stream. At the same time, exposing the polymer to prolonged excess heat causes the material itself to break down and carbonize. Next, we look for physical traps inside the machinery. Dead spots occur where material gets lodged in corners, along screw flights, or inside valves. That trapped plastic degrades over time until a fresh batch knocks it loose. A secondary issue is color residue. Leftover pigments from a previous run can stick to the barrel and streak into your new production lines, contaminating the batch exactly like degraded carbon. All of these issues are accelerated by high processing temperatures and stress. Overheating increases the overall risk of oxidation, speeding up the breakdown process for any resin or colorant left inside the system. Attempting to clean the machine without first diagnosing which of these 5 factors is occurring treats the symptoms while ignoring the root cause. The standard industry reaction is machines until a batch gets ruined, and then scramble to fix it. We need to replace that habit with proactive scheduled intervention. Waiting for failure operators into manual screw pulls. This labor-intensive process requires dismantling the equipment and taking your machine offline for hours to scrub the bare metal. Compare that emergency teardown to add to any protein schedule. Flushing the system regularly removes leftover material before it can heat up, oxidize, and carbonize into black specks. The core strategy here is actively driving down the recurrence rate of carbon buildup. This is the most reliable method to stop unplanned production stoppages before they happen. Scheduling brief purges between runs buys back hours of production capacity that would otherwise be permanently lost to unexpected maintenance. Now let's execute the cleaning protocol. Step 2 requires loading a specialized mechanical purging compound directly into the machine's hopper. It is critical that you avoid abrasive chemical cleaners here. Harsh abrasives permanently score the expensive metal of your barrels and screws, creating microscopic grooves where future resin will get trapped and burn. This diagram illustrates the specific mechanism we need. UniTemp PEKUTHERM utilizes thermoelastic expansion. As the compound heats up, it safely sponges outward into the hardest-to-reach screw flights, physically forcing the dark, degraded carbon buildup out of the nozzle. Relying on this thermoelastic action instead of destructive friction ensures you extract the hidden contamination without wearing down the lifespan of your processing equipment. Step 3 is the visual check. Run the mechanical purge continuously until the extrusion exiting the machine is completely clear of all streaks and contaminants. This reference details what we're clearing away. The carbon-crusted screw represents the before state. In the after state, a properly purged screw is gleaming bare metal. With clean components, your parts emerge flawless, confirming the machine is ready. This diagnostic and verification standard applies across all major plastic processing applications, from injection molding through film and sheet extrusion. Achieving a verified clear purge provides physical proof that the production line is genuinely reset and safe for high-tolerance manufacturing. Implementing this maintenance routine shifts purging from a reactive chore to a high-leverage optimization strategy. Applying this protocol locks in 3 specific outcomes. You minimize downtime, eliminate ruined scrap material, and guarantee cleaner production runs. The proven reliability behind this system comes directly from UniTemp PEKUTHERM's 40 years of industry expertise and domestic USA manufacturing. Integrating a mechanical purging protocol elevates the operational standard of your facility. It secures long-term profitability by keeping your lines moving.